Hello and welcome to another session of the AWS Primer series being done by Jyoti. And today she is going to talk about AWS Route 53. That is something different. I'm pretty sure it's going to be something different, isn't it, Jyoti?
Yep.
It's a different concept. So enjoy the session. And over to you, Jyoti.
Okay. Thank you, Brijesh. So, hi everyone. This is our part 22 of AWS Primer series. We are coming close to the end of the series. So, there are a couple of more topics left before we'll wrap up this ongoing series. The previous recording, you can find it on our TTC YouTube channel. So there is a playlist named with AWS Primer, so you can find all our previous recordings and sessions. Okay, and I see some of the new folks have joined today. So to just give them a brief. So guys, whenever I pick any topic, what I do is my first session on that topic is theory. So we cover everything theoretically, okay? And then the upcoming sessions, they are hands-on lab, okay? So today we'll covering about Route 53. So wherein we'll cover what do we mean by DNS, what is Route 53, different routing policies. Okay. Yeah. So this is our agenda. So when we say DNS, it is domain name server, right? So you all know in the world of networking or in the world of computer, how does one computer identify another computer or one device identify the other device? It's with their IP addresses, right? But for a user, for a human, it's very difficult to remember those IP addresses. Imagine having Facebook, okay, accessing Facebook using the IP address, right? So it won't be easier for everybody to remember those IP addresses. So what we do, we give a human readable name to those websites, right? And then there are servers which helps you to translate those human readable name to the IP address, okay? Yeah. So if we have to give an analogy, like what exactly is the role of DNS, it's same as your phone book, right? So maybe if I take an example of say Faz, okay? So maybe I saved his name as FAIZ. Somebody saved it as FAIZTTC, right? But ultimately it is mapping to one unique number. Yeah. So similarly, for a computer, every computer, every device has a unique IP address. Okay, it's just that we are giving some human readable name. So any website you see something like this, right? Say facebook.com, okay, or ttc meetup.ttc.com, right? So there are subparts to this human readable name. So the last part which you see, that is top level domain, right? So in the next few slides, you'll understand that these domains are also of two types. One is generic and another one is specific to a geography. For example, .in. So if any site has top level domain as .in, that means it's for India, right? And then these are just labels. We call them as labels. So it could be www.example.com. So your example is a label, right? So how does DNS help us to identify the exact IP address, okay, or exact server where I can access information related to this site, okay? So what happens is whenever on your computer you write something like that example.com, okay, so the request goes to your DNS resolver, okay. Now this DNS resolver goes and looks for, so let see, there are 13 root servers right now, and when we say root server, it means this top level domain. So for .org there would be one root server. What is the purpose of of those root servers? they'll tell you the information about the next part. Okay. So for example, when I write example.com, the request would go to a DNS resolver. Okay. Now the DNS resolver would go to the root server. Okay. So the root server in the case of example.com is your .com. Now .com would say, see, uh, it would tell you, okay, where to look for example, right? So it would go to the DNS resolver. It would say, okay, I don't know about www.example, but I know where is example server. Okay, so now your request would go to the another server, and finally the server which is able to give you the exact IP address. Okay, that we call it as a authoritative server. So usually you'll have hear a term like root server, name server, or your authoritative servers. So ultimately what these servers are helping you is, the end goal of this server is to give you the IP address for this website. Okay, you would see if there are some website which is being frequently accessed, maybe facebook.com, right? So every time you don't want that, okay, request, you write facebook.com on your website, then the request would go to a DNS resolver, then it would go to a root server, then root server would go to a top level domain server, and then finally to the authoritative server, right? So you want to avoid these calls. So what happens is, at times DNS resolver caches those information, but with, there is a TTL involved in the caching, which is time to live. So after, say, this you can set up, like after 4 hours it would get expired, and again the whole chain would start. So when you write example.com, again the information would flow like this, from a root server to a top level domain, and then to your exact, to a server which has exact IP address of your website. Okay, so read a little bit about DNS, and there are, like, when you query a DNS, the query is also of two type, but one is recursive and another one is iterative. So do give a read on these topics. Okay. So why did I tell you about the DNS? Okay. So your Route 53, it is a service for DNS, right? It's a scalable DNS service which Route 53 provides. Okay. And it has got three major functions. First one is your DNS registration. So Route 53 can act as a registrar. So when we say registrar, it's same as, remember, you see those advertisement on GoDaddy and all. So what do you do actually when you go to hosting.com, etc.? So they give you you register your domain. So what is the relevance of registering a domain? Now, if I say I have named my website as www.ttc.com. Now nobody else can have a same domain, right? So either you can register your domain using those third party tools like GoDaddy, Freenom, etc., or you can have Route 53 also for registering your domain. Okay. Second is, it helps you to route the internet traffic. Okay. So imagine like this, before AWS, right, before we had Route 53, we were using GoDaddy for registering our domain, right? Now what I did is, now I have migrated my system from on-prem to the AWS, right? So what AWS Route 53 helps you do here is, in GoDaddy, like when you go ahead and register your domain, there you can give a reference of your name servers, Route 50 name servers, which you have created in your account. So now whenever somebody would say www.ttc.com, okay, that was used, registration for that domain was done using GoDaddy. So the request would go to GoDaddy, and GoDaddy would route your traffic to Route 53. Okay. So that's the second purpose. It routes internet traffic. So routes internet traffic to the resources for your domain, right? And third is health check, right? So your Route 53, imagine you have a website. Okay. Let me turn my video on. Okay. So you'll have a website, then you'll have your Route 53. Okay, because your website has a English name and you want to map it to some IP address. Okay, so how do you get those IP address? For that you need a Route 53. there could be a possibility that Route 53 is mapped to your ELB's name, right? So for people who have attended my previous session, we discussed about elastic load balancer, right? Now that your elastic load balancer could be attached to your S3, could be attached to your EC2, right? So now your Route 53 can help you in doing the health check. Okay, so it can do a health check for your ELB if it is attached to ELB directly, or your Route 53 can help you do a health check for the resources like your S3 or your EC2 instances or your DynamoDB. Okay, so based upon the parameters, like if those resources are reachable, available, or functional, your traffic would be routed accordingly. Okay, and then from Route 53, as I told you, it using Route 53 you can register a domain. Okay, so it provides a support for both the types of domains. So the generic, for example, .org, that's a generic domain, right? Or it could be a geographic domain, for example, .in for India. Similarly, there would be something for UK, China, right? So it provides supports for both of them. Yeah, so it's not necessary that you are going to register your domain using Route 53 only. You can also use GoDaddy or other registrar. Okay, it's just that there then you have to do the mapping. Okay, in GoDaddy you have to provide the name server of your Route 53. Okay, I was just checking the chat in case there is something for me. Okay. Now some terms, again, for now, these terms might sound a little alien because we are studying about this topic for the first time. But the purpose of this first session on Route 53 is to make you well versed about these terms so that when we go ahead in next session and we are doing a lab, you can easily recall, oh, I had read something about the hosted zone. I had read something about name servers. Okay. So there's this concept in Route 53 which we call as a hosted zone. So consider it like whenever I'm going to create my domain using Route 53. Okay, what that means is I'm not creating my website. I mean, registering my website with GoDaddy. Rather, I'm registering using Route 53 itself. So the hosted zone would have same name as your domain name, for example, ttc.com. And now this hosted zone would have all the information about your domain, right? So it is a collection of records for your specified domain. Okay, so what kind of information it would have, right? It would tell you how your traffic needs to be routed, whether it's a domain or a subdomain. Okay, so what exactly is a subdomain? For example, you would have seen info@support.com, or let me say info@ttc.com or support@ttc.com. So these are your subdomains, right? Main is ttc.com, but then you have info or a support or HR or testing job. So these are your subdomains. So the hosted zone contains information about these things as well. So what kind of information? If somebody has requested info@ttc.com, then where exactly I need to route the traffic. Or if there is a request coming for hr@ttc.com, then on which server I need to route the traffic. Okay, so all these information is uh, contained in your hosted zone. Kind of consider this as a register having all the information about you. Okay, and then there are two types of a hosted zone: public. So as the name suggests, public is you can access it using the internet. Private, that means it is very specific to your VPC, right? Nobody else can access that information. And when you go ahead and manually create a hosted zone, so when you have to create a manually, when you have to create these hosted zone, when you have registered your domain using other platforms like GoDaddy. Remember, I told you at the beginning that if you have registered your website using GoDaddy, so in GoDaddy, you have to go ahead and add the name servers of your Route 53, which contains information about your resources, right? So when you go ahead and manually create these hosted zone, there are 5 things which gets created. And this is something which is unique for your domain and you don't have to change it. right? So there are like 4 name servers which gets created. So what are those name servers? It could be .com, .org, .uk, right? Exact, I don't remember, but yeah, those are like 4 unique which gets considered created. And there is one more thing which gets created, which we call it as SOA. So what is SOA? It contains information about your hosted servers. Okay. Yeah, again, all this would get clear when we'll do a lab, right? So I'll just pause for a while to see if anybody has any question, any doubts, or you all are with me till now. Guys, you can write in the chat for me, like, is it all clear, or you want me to repeat any topic for you? Faz, hello?
Yeah, Jyoti, I don't have any doubts. Let's wait if someone has any doubts from the participants.
Oh, I called your name because I thought whether my internet is
No,
still...
no. Yeah, it's fine. No, it's working fine.
Okay. Yeah. So, Seema, that's a good question. And I'll have a lab also on similar thing. Like that is what we do in a real world. So it's simple for now. Understand that there are 2 ways to route your traffic. One is you have your Route 53, right? Now Route 53 has information of directly has information about your web servers, or your Route 53, when it gets resolved to the IP address of your ELB, right? So what would happen? Your Route 53 would resolve the domain name, the English name, and it would map to the IP address of your ELB. Now rest of the work is taken care by the ELB. Okay. Yeah. And in the diagram also, you'll understand when I said how Route 53 and ELB are related. Okay, and that is how things are done in the real world. You don't map your Route 53 directly to the resources, because you have to take care of the load balancing as well. Okay, so now what kind of routing policies we have in Route 53? So there are basically 6 categories. First is simple, second failover, weighted, latency, geolocation, and multi-value. So let's understand with the example what these routing policies exactly mean. Okay. Okay. So as the name suggests, it randomly. So you have like remember your website, and you wanted that there is a disaster recovery, and also you have replicated your website on 3 EC2 instance in 3 different regions. Okay, so somebody wrote www.ttc.com, your request came to, I mean, from here, Route 53 helped you to resolve those names. Okay, like the name to the IP address, and now the request would go to any of these servers, right? And it won't consider the health of these instances. It would randomly get routed to any of these instances. Okay. So this is your simple routing policies. And as the name suggests, we should not go with the simple routing policy, because here you're not doing any health check, etc. So user experience won't be good, right? Now, failover routing policies. So again, this is used for a disaster recovery situation. So suppose this is the user came and wrote test.ttc.com. Again, the request went to Route 53, because if for every website, irrespective of it, whether it is hosted on AWS or not, the first request goes to your domain name server, because they help you to resolve those name to the IP addresses. Now there would be a active and a passive server, imagine that way, right? So if somehow your primary, so if everything is fine in normal days, your request would always go to this part, okay, which is your primary server. But in case of a disaster or in case of any issue which user faces here, okay, this Route 53 would do health check on this. If health check doesn't pass, so which is the other server where I need to route my traffic to? It's the secondary resource. Okay, so this kind of a failover routing policy, you can use it for your disaster recovery situations. Okay. Now, weighted routing policy. So as the name suggests, here what you're doing, you're splitting your traffic based on different weight. Okay, so for example, there are 10 users which are accessing my website. 8 of them I am going to send it to this, right? And 2 of them I'll send it to my second system. Okay, so this is another way to route your traffic. Yeah, so see, simple. This one should avoid because it doesn't consider the status of your resources. Okay, so once the IP address from a name IP address is resolved, randomly your request would go to any of the region or any of the instances. Okay, second is failover. So this would come into picture, like traffic would go to this particular part only when there is some issue here. Okay, third is weight, right? So you are assigning a weight, right? Okay, 80% of the time my traffic should get routed here, and 20% time it should get routed to this part. This is another interesting one. So latency routing policy. Here, one thing to remember is, irrespective of the region, right? Your traffic would always be routed to that server which has a minimum latency. Okay. So though the example we have given, there is a user from Singapore and then there is a user from US. So if in an ideal condition, we'll go, okay, the US user would always be routed to a US East region, and a Singapore user would always be routed to AP South Asia region. But in a scenario, maybe this is a user from Singapore. For him, the nearest region is AP South Asia, but maybe there is some issue and the latency is more here, right? So your traffic would ultimately get routed to a region where latency is less. Okay, but you also know, like the user latency would be less only to a place where user is closest to. So if Singapore user is closest to your South Asia, so request would always go to a South Asia region, right? But in case if there is some issue here, so instead of now your traffic getting routed to this, it would start getting routed to this particular region. Okay. Now, geolocation routing policy. So this is opposite of the latency routing. How opposite, and when this can be useful for us? Now, as a user, right, or as a owner of a website, I am not concerned with the latency. Okay, and which are those situations where you won't be considered, where you're okay to compromise with the latency? When you have compliance related things, for example, GDPR. Okay, so remember 3-4 years back we had this GDPR rules and compliance, right? So in that case, what would you do? Irrespective of the latency, you'll always route your user to their respective region only. You route the traffic for that user to the respective region. That means if somebody is from Europe who is trying to access your website, so if all the time you'll route that traffic to a region which is closest to Europe. Okay, here you won't consider latency, but in previous case we were considering latency. Before that, it was not latency or region, it was all about the weight assigned, right? And here it was for failover, right? So if something goes wrong here, the traffic would go. And simple as the name suggests, it's irrespective of health, region, latency, it would randomly route your traffic to any of the resources. Okay. What next? Multi-value routing policy. Okay. So for that, you have to understand, see, in every slide I had this from here, a record. What is this, a record? So it's a generic term in networking where a record is a resource in DNS that maps the name of the host computer or other network device to an IP address. Consider it as a notebook or a page which has all the details, right? So this a record would have, like, for everything, for the domain you are trying to access, it would have all the mappings, etc. So in case of multi-value routing policy, what you're doing is you are creating same name A records. Okay, so the a record which you create, they have same name, right? So you would have seen this in real life as well, right? When you are doing NS lookup, something like that, the IP keeps rotating, right? You don't get a single IP address. So what exactly is happening there? For the same name, there are multiple IP addresses. Okay. So I'll quickly revise whatever we studied, because that was the end of our session today, but some of us joined a little late. Okay, so first we studied about DNS. So what is DNS? We understood this with respect to a analogy of a phone book, right? So, or a contact list. So what is happening is, I am saving FAS as FAIZ, but somebody is saving FAS name as FIZ TTC enabler, right? But ultimately it is being mapped to a unique number which corresponds to FAS, right? So similarly, in the networking world, all the English names you have of a website, they correspond to a IP address, right? And the pattern looks something like this. You will have a top level domain, then your level 1, level 2, and there could be a multiple levels as well. And then we studied, okay, how does DNS resolves your name to IP address. So there are 3-4 servers which come into picture. So one is your top level root server, which are like 13 in number. So those root server are like .com, .org, .n, .uk. Okay, so these are your 13-14 root servers which you have. So whenever a user goes ahead and write in their web browser name of the site, okay, and your web browser is acting as a DNS client, okay, so the request would go first to the root server, then to your top level domain, and finally to your name server or authoritative server. They are kind of the same, but we call a server as a authoritative server. It's that server which finally gives you the IP address which corresponds to this website. Right now, see, with root server and TLD server, you were just getting routed from .org to .mozilla.org, right? But finally, developer.mozilla.org, it was being mapped to an IP address that was provided by your authoritative servers. Okay. And one point also it's important for us to remember is that when we say 13 root server, that doesn't mean that for every domain there would be just one server. There is a redundancy, like there would be with .com, there would be a multiple server, so that they can take care of those failover scenarios. Okay. So how did Route 53 come in picture? So Route 53 is AWS scalable DNS service, and it has 3 purpose. First is DNS registration. So right now we were using GoDaddy and some other platforms to register our domain. Now we can also leverage AWS Route 50 to register our domain. But that doesn't mean that if you have registered your domain on, say, GoDaddy, you won't be able to route your traffic to AWS, or you cannot go from on-prem to, what do you say, cloud, right? The only change you have to do is in GoDaddy, like where you have registered your domain, there you have to say now this name which is present in your GoDaddy, it is going to be mapped to Route 53's name server. And now once the traffic is routed to Route 53 name server, which corresponds to your account, rest it would be taken care of. Okay. Second, it helps you to route the internet traffic. And third, health check, which I was telling you. Okay, so your Route 53 continuously checks the health of ELB if it is attached to ELB, or to other resources like your EC2 instance, S3, etc. So based on the health check, it routes your traffic. And Route 53 also supports I'm sorry guys, Route 53 also supports generic and geographic domain. So generic, as I told you, it could be .org, .com, and geographic, it could be .in, .uk, .us. Okay. Then we studied about hosted zone. So it's like for any domain you have in your account, there would be a unique hosted zone. And that hosted zone would tell you how to route traffic for a domain or to a subdomain. And it is of two kinds, public and private. So as the name suggests, public is something you can access from internet, but private, it is specific to your VPC, right? Then finally, we studied about the various routing policies which Route 53 gives us. Simple, here traffic is randomly routed. In this case, you will have a primary and the backup. So if there is something goes wrong with primary, your traffic would get routed to your secondary servers. Weighted, again, traffic is routed based on the weight. Okay. Then latency, the region which would have a minimum latency, the traffic would be routed to that region. Geolocation, this is useful in case of compliance, wherein irrespective of latency, you always want to route a user to a specific region. Okay, so for example, for a Sri Lankan user, you always want to route a location or a region which is part of a Sri Lanka. Okay. And then multi-value routing policy, it's kind of for a single record you have multiple IP addresses mapped, so you're rotating your IP addresses. Yeah, so this is all what I had for theory on Route 53. What we'll study in the next session, lab. We'll do a couple of labs around Route 53. So some labs would involve these policies. Some lab would have a combination of your Route 53 and ELB. And then we'll also do a lab wherein the portion which I was telling you, that maybe you have registered domain using GoDaddy or Freenom. So how now your traffic gets routed from GoDaddy to your Route 53 name servers. So we'll do a couple of labs around that.
Okay, thank you, Jyoti, for this. It was like very helpful to know like how DNS works, how Route 53 works. Now, what I will do, I will allow the participants to talk. So if they have any questions or if they want to say something, they can do it directly without typing.
Okay. Guys, any question for me?
Hi, Jyoti. Seema here.
Okay. Hi, Seema.
Hi. No questions for me, but thank you. It was much more clearer. Route 53 is probably one of the weaker topics that I had. It's explained a little bit more for me. Thank you.
Thank you, Seema. Yeah.
Hey, hi Jyoti.
Hey, hi, Tara.
This lecture was, I am first time attending this. So basically I'm confused like whether I have to register any domain or AWS itself will register a domain for me. Is there any registration service for this, or there is something I am confusing?
So you have to register, Tara. Like for example, there are two ways by which you can register your domain, right? Using say GoDaddy, Freenom, hosting.com, etc. Or second is you can use Route 53 only to register your domain. So in both the cases, you'll be charged for it.
Okay.
Okay.
Thanks.
Okay.
Thank you, Seema. Thank you, Tara. So if you don't have any other questions or any feedback, so we will end this session today. Thank you for joining today, and we will see you next Saturday at the same time for the lab. Is it right, Jyoti? Or we'll be doing lab, right?
Yes.
Yeah, okay. Yes. Thank you so much, everyone, for joining. Have a happy weekend.
Okay.
Bye-bye.
Bye. Bye, guys. Thank you.